Hi everyone, I'm Kevin. I have a very special guest today. We have Mark Erikson, and he's the maintainer of Redux, and he's been the maintainer since at least 2016.
Hi, I'm Mark. I'm not the only Redux maintainer. For reference, Tim Dorr has also been one of the other primary maintainers since 2016. We've had a lot of various contributors over the years. A lot of that has been kind of like one-off features and stuff. Within the last couple years, Lenz Weber has been a major contributor to Redux Toolkit as well. But in a lot of ways, I've sort of become, I guess, kind of like the public face of Redux, if only because I spend way too much time on social media.
So when you started feeling like you could really take over the library was when React-Redux 5 came out. What changes did you make when that occurred?
For background, I got involved with Redux in the second half of 2015. I started learning it around that time, and I saw a bunch of the similar questions being asked all over the place and ended up contributing an FAQ page in early 2016. Dan gave me commit rights, and for the next few months, I just sort of helped clean up issues and continue to answer questions. Dan had gotten hired by Facebook to work on React and got busy with that. So by mid 2016, I think, he messaged myself and Tim Dorr and basically said, here's the library, here's the keys, have fun. For a while, I still really didn't feel like I owned the library in a sense. So I continued doing issue triage and cleanup and answering questions. React Redux version 4, I think, had come out in late 15 or early 16, and that had still been basically written by Dan. And it worked, but in mid 2016, an external user named Jim Bola filed an issue basically saying, I'd like to do some stuff with React Redux and Connect that it doesn't do right now, and could we rearrange things a certain way? And I was like, no, I don't think that really makes sense. And he came back like a month or two later and said, yeah, I've basically rewritten most of it from scratch. Do you think you like that? And I was very skeptical at first. I mean, let's face it, random users saying they've rewritten your whole library from scratch generally does not work out very well. But I started kind of throwing some questions at him about, like, have you considered this edge case, that usage scenario? And he kept listening to what I was asking and making the changes. And eventually I realized that A, he was serious about trying to do this work, and B, that based on the benchmarks he'd put together, his implementation was actually significantly faster than version 4 in a lot of ways. At that point, I actually kind of was like, okay, this looks like it's going to work out. Let's kind of start collaborating on this. I kind of shepherded that process through, looking at the current behavior, the current tests and implementation, and saying, okay, we need to make sure we handle this case. Have you tried tweaking that? And he ended up doing all the actual implementation work on it. So I think we ended up shipping version 5 in late 2016 or so. And that's probably where the version that most people used when they got to use Redux, because it was really only about a year and a half-ish after Redux came out that we released version 5.
Oh, so that wasn't that far. That wasn't that far along, actually.
Right. I mean, certainly Redux adoption had taken off in 2016, but I think probably in terms of absolute usage, version 5 is probably what most people actually got to use for the first time. It was during that process of having to answer those questions and having to understand how React Redux itself actually worked that I started to feel like I actually had the right to even say this is how it should behave.
Because of the rewrite, it's kind of like you own that part too. That was something that you could maintain. You knew everything about it. It was. I guess none of the was any legacy code still in there, or was it all gone?
It was pretty much almost entirely clean slate. And the biggest difference off the top of my head was that in version 4, most of the actual work of running, for example, like your map state to props function actually happened in the render method of the wrapper component. This rewrite in version 5 was the first one to move all that logic out into a set of separate subscription handlers that all executed purely outside of React. Basically, by the time those subscription handlers got done, we already knew if the component needed to re-render or not. At that point, it was basically almost like a dummy set state call just to force your own component to re-render at that point.
Yeah. So if you are you saying like if you don't have access to the force update function?
There's a little bit of a nuance of behavior in class components between force update and set state. I believe, set state will call should component update. Force update will not.
Oh,
And
interesting.
at the time, our implementation of Connect was still a class component because that's all that existed. The way it worked was the selector would run and we would call this dot set state, but with an empty object purely to queue the
Yeah.
update. But then we did an additional check in should component update to double check things or something along that line. Call set state with an empty object just to queue the update and it'll run. All that matters is that you called set state at all.
Interesting. Okay.
Whereas with the hooks, both use state and use reducer do actually rely on immutable updates. They expect that what you pass in is a new state value reference, and they both do an early bailout even before queuing the update to check. And if you pass in a new value, they will opt out early and not even schedule the render. Or sorry, if you pass in an identical value, they'll bail out early.
So something I want to show first is how the connect function even worked, because that's probably people listening might not be familiar with it. So like the connect function is a higher order component that wraps your component. It provides access to the Redux store, and it passes. You'll give it a function, and then whatever you return from that function as an object will be then passed. Those properties of that object will be merged into your component's props and then passed into your component.
It's worth briefly reviewing how store subscriptions work and how React-Redux works with the UI in general. A couple years back, I wrote an extensive post about the history and implementation of React-Redux, where I started from scratch and explained all the principles, and I explained a lot of the history of the different versions of React-Redux. To recap, a Redux store, you can write an equivalent of a Redux store in about 25 lines. And you can see this example here. We basically just keep the state, keep the reducer. We store a list of listeners, and every time you dispatch, we run the reducer, save the new state, and run the listeners. And the listeners are probably going to call store.getState to get the latest value and see what it looks like. Your typical update cycle looks roughly like this. You create a store, you have some kind of a subscription function, and in that subscription function, you're probably going to get the state, narrow it down to just the piece of data that this component cares about, update the UI with that data, you do an initial render with the initial state, you subscribe to the updates, and then every time an action is dispatched, you rerun the process of get the state, pull out the piece you care about, update the UI.
I'd like to take a deeper look at this. So you said we're creating a store, and then we're subscribing to the store already, even before we've done anything to it. This is to use Redux without React.
Right.
Yeah.
And the point is that like what React-Redux does is just a fancier version of this exact sequence of logic.
Yeah, there's a lot more code in the React-Redux implementation. So the render function here is mimicking what React would do when it renders a component.
Right. This is really the Redux subscription portion and re-render section. Let's actually look at an example of what Connect does. So this is and Dan actually wrote a miniature version of Connect in a GIST about a year after Redux was released. So I copy pasted it into my blog post.
So this is the original implementation or just a mock-up?
Just like that Redux store that I showed a minute ago was like a 25-line mini version that does roughly the same thing. This is also like a mini version of Connect that does the same thing conceptually, but is very different than the actual implementation. Like you said, Connect is a higher order component. So we start with taking our map state and map dispatch arguments so that we know how are we interacting with the Redux store in this case. How do we extract data? How do we dispatch actions? And Connect is actually a little bit goofy in that it doesn't just immediately return the wrapper component. It returns a second function that then takes the wrapper component. The reasoning behind this was like maybe you want to set up your map state and map dispatch once, and then you want to wrap multiple different components with the same set of logic.
Yeah, I've done that before too, where you'll make a select function and you would pass that to your map state to props on multiple components that use Connect. and they'll all be getting the same state, or you could combine multiple states.
Right. You could call connect once, pass in map state and dispatch, and then take the returned connector function, for lack of a better term, and call that multiple times with a different component every time. And they would each get the same map state and the same map dispatch.
Oh,
Behavior.
I've never used it that way, but I see what you're saying now. That's why when you call
That's
connect,
why we
you
have
pass
the
in
double
those,
function call
yeah,
with connect.
and that's why your component goes last, because it's functional.
Yep.
So you can.
Yep.
I've never thought to use it that way.
It's kind of like a currying kind of a thing.
Yeah. But the thing is, like, why? I almost feel like, why haven't I done that? I guess it's less explicit. Like, having your selectors in there defined in your connect function would make it more clear what's actually going on without exporting it. But I get it, because the currying makes sense.
Yeah.
Yes.
Realistically speaking, almost no one really ever used that pattern. Although I will say that if you look at the React-Redux docs right now, so to be clear, we recommend using the hooks API as the default today for a whole bunch of reasons, but there's obviously lots and lots of code out there that still relies on connect. And if you look at our docs and you look at the TypeScript page, connect is really, really hard to type correctly with TypeScript. And it turns out there's an interesting pattern that came about with the React-Redux type defs, where if you use this pattern and you call connect with map state and map dispatch by itself first, it's actually possible to infer the type of the props that will be passed to your own component. And then you can use that to define your actual component later and get the types correct, rather than having to manually pass in like props from map state, props from map dispatch, et cetera, all as generic arguments to connect. Again, like one of the reasons to use the hooks is that they work way better with TypeScript, but this is actually a place where I have seen that separate the connect call pattern being used.
Okay, that makes sense. This connect function, I want to take a quick look at it. Now, I personally don't like the connect method, which is why I tried to make that render props component in the past, which I did use it at a different company, but then I saw the downfall of it, which was either you got to not re-render when children updates, or you've got to always re-render. So it causes, it doesn't get the same performance benefits.
Yep.
And to do so, you would it's messed up. It doesn't work as you expect. So then I would like to look at this, and then I want to see how the hooks are different.
Sure.
So this one in particular, what it does is it creates the unsubscribe function when it mounts. So it's actually when it mounts and not in the constructor.
Correct. And the reason for that, strictly speaking, up through React 17, we could have gotten away with doing it in the constructor. But the React team has always said that component did mount is the right place semantically to establish any kind of a subscription, because at that point you know that the component is mounted, it is attached to the page, and it is now safe to go do that kind of work. React 18, it's very possible for components to be constructed but never actually mounted, and in that instance could get thrown away if the render pass gets interrupted during concurrent rendering.
Concurrent, yeah, okay. So that's because of concurrent mode.
But like historically speaking, even before concurrent rendering was a thing, the React team has always said that component did mount was the right place to do any kind of initial data fetching, subscriptions, that kind of thing.
Interesting. It's also, with function components, I guess technically you could call it at the top, but then it happens every time. And so that's why you have use effect. So this would have gone into use effect if it's also done in a function component.
Basically, yes. And we'll actually, we can see that in the use selector source here in a couple minutes.
So when you subscribe now in the did mount instead of in the constructor, there's a big problem there, and the problem is you have to return something, and that you could return children, but you wouldn't be passing it props anymore. Do you just avoid rendering the children and then you pass the props when they're available?
Good question. I would have to double check the guts of the real implementation to see exactly where the sequencing is.
Oh, no. I see it there. You subscribe in the did mount, but you still have the get state function. I see that line there where it says map state.
Roughly, yeah.
Yeah, so you always have access to the store, even if you're not subscribed. I forgot about that.
Right. So we get the store via context, and in fact, this miniature example is completely skipping the part about where do we get the store from.
Yeah. Because where it comes from the legacy React context.
Yeah, up through version 5, the store was passed down in legacy context. Starting in version 6, we passed it down via new context, which was actually half the reason to write version 6 in the first place. The point is, ultimately, what Connect actually does is we forward all the props from the wrapper component to your component. We call map state, and whatever object it returns gets forwarded as props to this component. And we call map dispatch, and whatever props it returns also get forwarded to your own component. In one sense, it's not that hard conceptually, but in another sense, it is really hard conceptually. And I've seen a lot of people get very, very confused by the whole higher order components thing and what props coming from where. I don't know how.
That's my biggest issue.
Yeah.
Actually, the biggest issue I have is that the ESLint rules require prop types for every single imported prop. And then I don't want to put prop types for stuff that's coming from the Redux store because I don't necessarily own if I put it in prop types, that's the API for somebody to pass stuff into my component and not necessarily stuff that I'm accepting into my component from the connect function. So it makes it a little confusing from my perspective to do that kind of stuff.
Yeah, and we actually have to do there's a step inside of Connect where we call a function called hoist react statics. So if you attach a static prop types to your own component, it ends up effectively moving that up to the wrapper component so that prop types checks actually run on the wrapper.
Yeah. So that's actually really good because the official React memo function where you wrap a component in a memo, similar to that you do with Connect, that function does not hoist your props, which makes it very difficult to do .prop types if you're checking the props of child component into your parent component for some reason if you want to do that. These days, I would just say put prop types.any if you're just going to pass it through. But that was a problem I ran into in the past as well, is because the memo did not return a component that was exactly the same as the component you gave it. And so it became more difficult. Now, something else we should probably note about the connect function here is that the connect function memoizes your component.
Yes.
Which was lost when we moved to hooks.
And exactly. Connect has always acted like the equivalent of a React.pure component or a should component false or a React.memo, in that if the parent component above this re-renders and the props it passes in are the same, your own component will not re-render. Now, there's a little bit of nuance here because it's actually slightly more complex than that. The real factor is not if the parent props changed. The real factor is if the combination of these three sets of props together changed. This actually gets run in the real Connect implementation as one single step that results in a final merged props object, and so the actual diff check is against the result of merged props, not against the incoming parent props. But for all intents and purposes, in normal usage, if the incoming parent props have changed, then yes, the output of merge props will have changed, and it'll have to re-render. That can be done because Connect wraps your own component. useSelector runs inside of your component. It does not wrap it, and therefore, if the parent component re-renders, normal React rendering kicks in, React re-renders recursively, and so it's really up to you to add a React.memo call on your own component to get that same kind of behavior. Spoiler alert, if you look at Connect as of version 7, we just use React.memo.
Oh, interesting. That's actually really cool. I didn't know you were doing that. Yeah, so instead of having your own memo function, you've got that one. Now, I'm assuming you just pass it the merged object because it does a shallow... React.memo is going to do a shallow comparison of the props. So if you merge the object ahead of time and just pass it to memo, then it'll figure it out.
So, tell you what, let's actually dig in to some of the actual source for the moment, and I was actually looking at this recently because we are actually right now in the process of converting the React-Redux codebase to TypeScript finally.
Wow.
For all these years, React-Redux has been written in plain JavaScript, and the TypeScript type defs have been maintained separately by the community in the definitely typed repository. For React-Redux version 8, which will probably be coming up later this year in conjunction with React 18, I decided it was finally time for us to convert the codebase to TypeScript. So as of right now, as we're recording this, we have a TypeScript port branch in our repo, and I basically just put out a call to help to the community saying, hi, would people like to help convert some of these files over. Like 6 or 7 different people have each converted like a handful of files and done some of the tooling changes. And I actually ended up tackling the Connect implementation a week or two ago. So right now, it's all still on a branch. It's in an integration branch that hasn't been merged in yet. But we've got all the code converted. We're just getting the rest of the tests converted over. Once the tests are converted, I'll merge that PR into master, and then it'll just kind of hang there until we're ready to make any actual behavior changes related to React 18. What you're about to see is truly the latest and greatest version of the code base that isn't even on master yet.
Oh, that's cool.
One thing to understand about the version 5 implementation, which has carried over to versions 6 and 7, is that the author who did that rewrite separated out the logic into what he called Connect and Connect Advanced. And he had a very specific use case in mind for himself that caused him to write it that way. Connect Advanced, as of right now, still in the code base, has the actual guts of the logic. And Connect is actually a specific set of inputs to Connect Advanced that implements the whole map state, map dispatch, merge props thing. Connect Advanced doesn't know anything about those arguments.
If you renamed Connect Advanced, because this is something I had problems with when I looked at the source code, I was like, I don't understand why there are 2 of these. And also, I looked at Connect first, and I was like, oh, it's calling Connect Advanced, and I was like, what is this? You know, so what would you rename Connect Advanced to if you had to do that?
Nothing, because it's going to go away.
Okay.
We actually posted like all the way back in 2019 saying, yeah, Connect Advanced is deprecated and it's going to disappear in the next major version. Well, this is the next major version.
Oh, interesting.
So we went ahead and converted it to TypeScript as is because I wanted to try to exactly match the existing external type defs and behavior and tests exactly first before we start refactoring it.
That makes complete sense. So what you're doing there, the strategy is that you're going to convert everything as is so you don't break anything. And then when you go to refactor, you've already got everything set up and you feel more confident.
And typed.
And so now when you change it, compiler should start warning you when stuff is not working as expected.
Yep. Now, I suspect that there's probably, I almost guarantee that there's still some discrepancies with the type defs between what we have in this code right now versus what's in the external type defs. We did literally copy paste over many of the type declarations that the community had written in those type defs because they're there and they're free work. The work's been done.
Uh-huh.
And on top of that, we want to match the types as much as possible to minimize breaking changes.
Yeah.
There probably will be some breaking changes with the types, but we want to start from a known good starting point before we really start shuffling pieces around. Let's actually back up and talk a little bit about some of the history of the versions real fast. So like I said, version 5 came out in late 2016, and that was a complete rewrite from scratch.
Version 5 of React-Redux.
React-Redux.
Yeah, because Redux was, I think, still at 2 or 3 at that point.
Yeah, I think we put out Redux Core version 4.0 in maybe like 2018, and even that was really just like some change to the type defs mostly. Version 5 stayed around for about 3 years, and in mid 2018, the React team started discussing their plans for suspense and concurrent mode and all this other nifty stuff. And they actually reached out to the Redux team, the MobX team, and the Apollo team, and were kind of trying to give us a heads up on where they were going so we could start thinking about like what kinds of compatibility changes we might need to make to our libraries. And React 16.3 with new context had come out by that point. I wanted to actually kind of get ahead of the curve a little bit. We knew we would have to have a major version to switch from passing down the store in old context to new context. Now, the fact that the store is in context was never part of our public API, but everybody knew it was there. And so there were a lot of libraries like Redux Form and a bunch of others that were accessing this .context.store because they knew it was there. And it worked.
I didn't know that. Oh,
yeah.
No, that's not good.
Oh, yeah. It was an implementation detail. but it was right there in plain sight. Everybody knew it was there. That was one of the reasons why version 6 was a major version, because we knew that would break a lot of people. But on top of that, I wanted to try to kind of get ahead of where the React team was going with this concurrent stuff. And with new context coming out, one of the big things that the React team was concerned about was this idea of tearing. Basically, like, if React is able to pause its rendering work in the middle and then pick it up later, now other things could happen in the system while the rendering pass is paused, like, say, dispatching a Redux action. So what happens if, say, React renders the top half of your component tree with state A and pauses, and in the middle of that pause, an action is dispatched, and then it picks up and it renders the second half of your tree with state B. Well, now your component tree is in an inconsistent output because half of it was rendered with state A and half of it was rendered with state B. One of the things about context is that React guarantees that the entire tree sees the same consistent value that you put into a context provider through the entire rest of the tree for that render pass.
Except that the store doesn't update the context.
Well, that's the thing. In version 6, it did.
Okay.
I said earlier that in version 4, every component was a separate subscriber to the store, but we did the calculation of map state and such in render functions, actually. In version 5, every component was a separate subscriber to the store, but we do the calculations outside of React. Only force the component to render if we know that the results of map state and such have changed. And then it basically just reads the already calculated props and passes them down. Version 6 changed that completely. In version 6, the provider component subscribed to the store, and on every dispatched action, it immediately called set state with the entire new Redux state object.
Oh no.
We put that into context. I see the head desk.
Yeah, it's not good. It's so not good. Oh, no.
Know where and why this became a problem. We put the entire new state value into context. And the problem was, at the time, we still only had class components. So the only way to access context in class components was via render props and then doing the logic in render again. And we had to do some kind of stupid hacks to make this work, but it did. And there were some upsides. One was that there was a consistent state value the entire way through. Version 6, we had the provider subscribe to the store. And on every dispatch, it would set state and pass the new state value down via context. And at the time, because hooks didn't exist yet, we only had class components, the only way to read context was with render props inside of the render logic.
At that time, it was the context.consumer component that would then take children, which is a function, and then you would pass in your props that way into your component from that context.
Yep. And so that meant, in a sense, we were now back to the version 4 scheme of doing the calculation of map state and the props and everything in the middle of the render pass itself. And there were actually some benefits to doing it this way, and the biggest one was that we got the top-down update behavior for free. So Connect has always had this invariant that when it calls your map state function, you know how you can ask for own props to be passed in as a second argument to map state? Well, because of how React lifecycle methods run bottom to top, it's actually always been possible for child components to subscribe before their parents.
So React is rendering components from the child first?
React renders top down, but when it fires life cycles and hooks, they run bottom to top in that first mount.
Oh, interesting. So that must be a logistical problem for Connect.
Yes.
Is that also why you're subscribing to the previous store's subscriber and you have like a layering of those?
Exactly. Connect has always tried to guarantee that when your map state runs, we can pass in the latest props from the parent. But if grandchild C subscribes before parent B before grandparent A or whatever, then the child's subscription would have run first, and it could be re-rendering before the parent has a chance to get new data from the store and re-render and pass down new prompts. So in order to maintain that invariant, in version 5, the contributor who wrote it came up with this nested subscription scheme. Nested components actually subscribed not to the store, but to their nearest connected ancestor. So the store triggers the top layer of subscribers. They re-render, their component did update executes, and then we cascade the updates down to the next layer of subscribers who have a chance to re-render with the latest props and the latest state and so on down the tree. It's also very hacky when you think about it, but it did work.
Yeah.
And the problem was we had to have all this like custom subscription handling stuff in version 5 to make that work. In version 6, we got to throw all that away because we were doing the logic in rendering, and React naturally renders top down. And if a parent re-renders a child component out of existence, then the child just never runs. So it actually simplified our implementation dramatically.
Aside from the performance.
Well, and it looked like it was going where the React team was headed. Unfortunately, performance was the issue. I had run some benchmarks, and I could tell that version 6 was slower than version 5, but it was also like a purely synthetic stress test. And I was like, well, maybe in the real world, this won't matter. I was wrong. And I'm not afraid to say that. So like if you think about it, it was actually really like the absolute worst case scenario where for every Redux dispatch, we were forcing a re-render from the root of the component tree, and React had to iterate the entire tree and re-render half your components, the wrappers, just to see if the other half, your own components, would actually re-render. In retrospect, it's amazing it worked as well as it did. Within the first couple months of release, we had enough people filing issues saying that they were seeing performance degradation that I was like, you know what? It was a nice try, but no, this just didn't work out. So in early 2019, I filed a roadmap issue. I think it's React-Redux issue 1177, which, yes, is burned into my brain, where I said, okay, version 6 didn't work out. Version 7, we're going back to direct subscriptions. Also, the whole hooks thing just happened a couple months ago. Like, maybe we should figure out how to use those.
Oh, yeah.
And so I had this like whole big, like, I want to get the community involved in the process of figuring out how to do version 7. In the end, it turned out to be basically just me.
Oh, no.
I wrote this whole big issue. A lot of people gave thumbs up. A lot of people gave comments. And a few weeks later, I happened to be on a business trip, and I had some free time on my hands back at the hotel. And I just started playing around with, what if I re-implement Connect from scratch using hooks? And you can see my comments in that thread where it's like, well, I kind of have it passing most of the tests, but it seems very, very slow. And like literally, I tried wrapping it in React.memo, and suddenly the performance boosted dramatically, basically up to where it should have been.
Yeah. That would do it, right? That's the one thing missing.
Yep, that ended up as version 7. I basically did it by myself in about 3 or 4 weeks, just hacking on it. I also went in and I added some batching. Previously, with the way all the subscription stuff was set up, every dispatch would end up triggering a whole bunch of different sub-subscriptions and executions and whatnot. And I added use of React's unstable batched updates API directly into our internal subscription class, so that the nested updates themselves would get batched correctly.
Okay, so I'm completely confused here.
Okay.
So there's an API in React that is for concurrent mode, but that like
not even for concurrent mode.
Okay.
This has existed for years.
Okay,
so you know how if you call set state in a React event handler, like you set state 3 times in a click handler, you get 1 render.
With the class components.
So same thing with hooks.
I thought with hooks there's something new that they introduced to do the batching in React 18.
Same mechanism. So what it is that React has its own event mechanism. React knows when it's calling your event handler, and React's reconciler has an internal set of functionality called batching, and it basically wraps your event handler in a callback. Loosely put, it just sets an internal flag like is batching true. And as long as that flag's true, when state updates get queued, it just saves them all for later and runs them together. So that's why if you call set state multiple times in an event handler, you get one render at the end. React does that automatically internally for events, but that is exposed as an API called unstable batched updates from both React DOM and React Native. And that's the trick. It's a reconciler API, not a React core package API.
And so you said there was something about dispatch, that you had multiple dispatches. And before we even get there, let me explain the hooks. So there are two hooks with Redux that you built at this time. There was the use selector. Thank you for the naming. It's better than use map state to props.
Yep.
Yeah. And then use dispatch. So you get the actual dispatch function and explicitly call dispatch where you want it, instead of having the map dispatch to props, which is to me always confusing to figure out, was this function wrapped in dispatch or not?
Yep.
And the import name was the same as the version in the component. So
I said a minute ago that as of version 5, we have this whole nested, tiered, cascading subscription behavior inside of Connect.
Yeah.
The issue was that depending on where and how the dispatches happen and how things happen internally, you would end up basically getting a whole series of nested re-renders, even from like one action being dispatched.
Even in version 5?
In version 5 specifically. In version 6, you didn't see that because it was all one big render pass. In version 7, I brought back the nested subscription because we were going back to doing the checking outside of React and cascading things downwards. But I added use of this batching API inside the subscription class that we use to try to minimize the number of internal re-renders that happen from one dispatch. If we look at, well, let's actually look at some of the code here for version 7, and this is the Connect Advanced API that is the core of Connect. Okay, so this internal Connect Advanced function, which is exposed, but almost no one uses it publicly, takes a set of options for how it transforms state and props into the data that gets passed to the actual component. It has some options for, like, you can give it a custom context instance to pass down the store. Do you want to forward a ref to the actual component and whatnot? And if we get down here, this function right here is the actual wrapper component that will run as of version 7. It is a function component that takes a set of props, the ones that have been passed down or that extracted from Connect, as well as whatever was passed from the parent. And the first thing we're going to do is we're going to extract out any forwarded ref and any potential like custom context instance that was used. We try to memoize that, so we only do it once.
Custom context? You mean like...
So we actually use a singleton context instance internally to pass down the Redux store. And so it's literally this instance right here. There are rare cases where you might want to change this. Like if two different parts of your React component tree somehow need to use like two different Redux stores, you can't put it in a provider because then that tree would override. Like there's very rare cases when you would ever want to consider doing this.
Yeah, I'm one of the people that had a use case for that. I figured out a way around it, but it was also by not using React-Redux for that particular use case.
Yep. We support passing a custom context instance to Connect itself as an option, or even potentially, I guess, as a prop to the component. I think it's been a while. So either way, we figure out which context we're supposed to use. We grab the value. Technically speaking, you can also pass the store itself as a prop. That's a weird little leftover legacy thing that you can do.
Yeah, I had no clue you could do that. Okay.
It was mostly useful for tests. Like if you were writing a test for a connected component, you could pass in a store.
Oh, I always wrapped it in the provider.
But yeah, but like that didn't help if there were nested connected components rendered by the one you're testing.
Oh, you mean passing in the store didn't help if they were nested. Yeah. But if you wrapped the provider, it would
exactly
fix it. Yeah,
exactly. So we got to do another whole dance to figure out are we getting the store from the props or from the context. So by the time we get down here, we now at least have the store. This effectively creates like the map state handling one level removed. And then we need to create the subscription to either the store itself or the nearest connected ancestor component. We're looking at this piece of code right here, and I actually just reworked this the other day. Previously, subscription was a class instance that so we would call new subscription right here. And on this branch, literally like a week or two ago, I converted it over to be a closure because I figured out that could save us like 300 bytes.
Oh, okay. You mean like total in the file, or like
minified release.
Okay, I mean, yeah, that's like that's library author stuff right there.
Yep. We create a subscription, and if like the store or like the context value change, we need to recreate it. But realistically, it's one subscription instance for the life of the component. And then we need to pass down a modified version of the context value that has the just created subscription instance for this component, so that when some other component inside of this wants to subscribe, they subscribe to this subscription instead of the one further up. So that gives us that nested hierarchy of subscriptions.
You almost think of it like an onion of subscriptions.
Yep.
Yeah, because the parent has its own subscription. Well, actually, the provider has its subscription, and then the parent makes one, and then the next parent makes one. Yeah.
Yep. Eventually, we get down here. We've got some logic that will actually calculate what the child props should be based on running effectively your map state and other stuff. We've got some complicated logic in here that's changed over time, where we've tried to optimize things so we don't accidentally capture and close over some variables and cause memory leaks.
Is this all required, or is it legacy?
This stuff right here, previously there was a lot of logic that was inline inside of this component, and then people said, well, I'm seeing like some memory being used and not going away, and it was because we were closing over certain variables. And so by like extracting some of the logic to technically be separate hooks with arguments, we stopped closing over it, and it was able to be reclaimed as necessary.
Wow, that's
there's all kinds of nuances and edge cases in here that you've never thought about.
Yeah, because I built my own, React-Redux library multiple times. Not exactly this one, but I never got this into detail. I feel like I've missed a bunch of stuff.
Here's another one. In class components, we subscribed in component did mount, and we ran updates in component did update. Those are both commit phase life cycles. React runs those synchronously at the end of the render pass right after updating the DOM. Use effect runs on a short timeout, so there's a little bit of a delay and the browser has a chance to paint. And what we found was that if we subscribed in use effect, it was possible to actually potentially miss some updates that might have happened in between. So we wanted to run the store subscriptions in use layout effect, which is a commit phase method like the class component methods. But if you call use layout effect in a node server rendering environment, React prints this stupidly annoying warning message telling you that use layout effect won't run on the server. And the thing is, use effect doesn't run on the server either, but they don't print a warning for that. And there's a mile-long issue thread in the React repo with like 300 comments with people complaining about this. I have several comments in that thread. The hacky workaround that someone else came up with that we adopted is we have a file that we've dubbed use isomorphic layout effect, where it tries to determine based on variables like window and document.
Dude.
Basically, are we running in the browser or node? And if we're running under node, we're going to point this at use effect, which still doesn't run, but it's also not going to warn us at all.
Yeah, it's so weird. Look, I get it, and this is the weirdest thing that you have to do that. Like, why don't they just remove the warning?
I know. So when you see this reference to a use isomorphic layout effect, it's really supposed to be a use layout effect with the knowledge that this will never run on the server and no warning from React.
Okay.
And then the with args bit is we had to extract the logic outside of the component to avoid closing over things and causing memory leaks.
Yes.
So you see, it's just like one step at a time. One little requirement causes further complexity.
Yeah, we're at line 418, and we're not to the end of the file yet.
Yep.
Yeah, I mean, this is a lot of stuff in here.
Then we get down to this part, and you might be wondering, why are we calling use memo around just rendering an element, or for that matter, down here? And it's because React has a specific optimization internally that's been there for years, but very few people know about this. We know about how React.memo and should component update and pure component can be used on a component to decide if it should re-render or not. But when we do rendering, normally we return JSX. Every JSX tag gets turned into a React.createElement call. Every call to create element returns a new object that has like a type field in there with like your component or a string like div. Normally, every render pass is returning a completely new set of element objects every time. But if you somehow return the exact same element object reference at the same point in the output as the last time that you rendered, React will see that those elements are triple equals identical, and it will skip re-rendering that child component in its subtree. It's almost like a React.memo, but controlled by the parent component doing the rendering. And React-Redux version 4 actually even used that optimization. I brought it back for version 7, and we're doing it here. So we're memoizing, rendering the child element so that if the child props have not changed, we skip rendering the child component.
That's really impressive. In fact, I've wondered about this myself because I was like, how does React know if children has changed? Doesn't it always change? You know, like that's kind of been in my mind because I know that it will do a VDOM diff if you let this go through. It'll have to do that. But here, we don't have to use the virtual DOM to do the diffing because you're doing it with the use memo, which is really cool. This I want to go back to that and go into it a little bit more. So what you're doing here is you're using the use memo function to memoize the component itself.
Yep, or rather the element that tells React to render that component.
Yeah, and then you're giving React back the same reference of the in the second one here at line 467, we're returning back that provider component with the wrapped component that is also memoized separately.
Yep.
Yes, and we can avoid re-rendering this altogether, which is a really insane performance move.
Yep. And the reason there's two different bits here is because of some very, very rarely used options for Connect Advanced. Strictly speaking, you can configure this to not handle state changes at all. I don't know why you would want to do that, but that option exists in the version 5 code base, and so it still exists now. Strictly speaking, if that flag was turned off, we would only use this piece. But in normal behavior, we are handling state changes. We do need to pass down that nested subscription context. And so we actually have to stick this piece around the component that we're going to render.
The only reason I might see like the should handle state changes would exist is because if because I've done this in my apps where everything is in Redux, therefore I'm using pure components only, or you know, memoized function components or whatever, right? And so then you wouldn't have any internal component state, and that might be a reason for it. But that optimization would have to be put in every connect function, which seems a little obtuse to have to do that every time.
Yep. It is also possible to configure connect to not avoid re-renders when the parent component renders. Basically, this option right here controls whether it acts like a React.memo or a pure component at the outer props level. And oh look, we are literally just wrapping it in React.memo as of version 7.
So what's pure mode?
If for some reason you wanted your component to always re-render when the parent does, regardless of whether the props changed or not, you could set pure to false.
Yeah, this is the fourth argument to the connect function where you pass it an object of options, and pure is one of the options you can use. By default set to true, but you can change it to false.
You can see that an awful lot of the behavior in this file is the combination of connect versus connect advanced being split into two APIs, and all the various options and edge cases and overrides that have accumulated in connect over the years. And I'm not saying that the API was bad per se. It's a very JavaScripty API. Like, you've got optional arguments, and some of those options can be null or functions that return functions or objects full of functions. Like it's a very JavaScripty API. And one of the observations I've made since I learned TypeScript a few years ago is that TypeScript pushes you towards writing simpler API designs that are easier to static type. I am very thankful we did not maintain the React-Redux type defs directly in our repository, because frankly, these type defs are insane because the internals of Connect are insane. And trying to track all that is just ridiculous. For point of comparison, let's look at how useSelector behaves. First off, you'll note that the file's a lot shorter.
Oh, yeah.
The first observation here is that we did actually have something added after the original release of the hooks API, where someone said, well, with Connect, I can use a custom context, and I can't do that with a hook. The hooks are always using the one single context instance. And so somebody contributed a factory function that lets you pass in the context instance and gives you back the actual hook. And so you can see that the default useSelector instance is just calling that factory, and it defaults to our standard context. But if we ignore that section of this, it's really only about 100 lines. The logic here is mostly easier to follow. We have some types here now. Yay. Like with Connect, we have to create an instance of a subscription so that we can get the store and subscribe to it. But because hooks are inside of components, they don't wrap components, we can't do the nested tiered hierarchy of updates here. Effectively speaking, unless you've got a connect in the middle, all these will be subscribing directly to the store again in practice. We don't have to worry about any of that element memoization or providers or anything like that. It's just subscribe to the store and get some data. We do have a bit of complexity about needing to keep around some various values for reference. Typically, most logic or most components end up defining a selector instance inline when they call useSelector. That means we're getting a new selector every time we render. We got to save that somewhere. If an error was thrown while handling a dispatch, we're actually going to end up forcing a re-render. And then we kind of either hope that it goes away and everything runs fine, or if the error actually still does occur, we're going to throw it and force things to explode. So we got to keep that around. And we also have to keep around the latest selected state so that we can diff it and see if we need to re-render or not. You'll also see that we are actually calling store.getState in the middle of rendering. Strictly speaking, this is a little bit like impure and not ideal, but that's what you have to do when you're dealing with an external state handler. We've got some logic that figures out basically, do we need to rerun the selector during this rendering pass? And it's basically, did the state change? Did the selector change? Is there an error?
Yeah, so you're always running the selector first and then doing the comparison there. Because you're not caring if all of the state is changed. You're just caring if that specific piece that somebody cares about is changing.
Exactly. So we do a little dance to figure out if we need to run the selector again. And if we do actually run it, we do some checks to see if the data has changed. This is an interesting little bit that I'm not sure if most people are aware of. I mentioned earlier the order of life cycles and effects. It depends on kind of like what phase we're in and what kind of a life cycle we're talking about. On mount, if a whole bunch of components mount at the same time, React is going to execute things kind of in a bottom-up sequence. And actually, I should double check this. I said on mount. I think it actually is all the time now that I think about it. But within one component, effects will run in the order that they are declared.
Yes.
So here, by having this layout effect before this layout effect, we guarantee that these refs will have their data filled out before any of the code in here ever executes.
I'm curious, you don't have a second arg in that one at 63.
Right. So we're wanting to reassign these every time the selector runs, because maybe like the data extracted from the store did just change.
Is there a difference between putting it in your function in your hook directly versus putting it in an effect like this?
Very, very slightly, and I've seen lots of people argue, well, I can just throw that ref mutation directly into the render logic and it works just fine. Well, yeah, it works just fine. It runs. It's not strictly correct. And that is actually where some of like the concurrent rendering stuff will start to get you into trouble.
Yep. I knew it. Oh, okay. Shoot. I might have to change something.
Yep. So ultimately, we're making sure that we've got the references to the latest selector, state, selected state, etc., all saved. Effectively on mount for all intents and purposes. We will subscribe to the store. We've got our check for updates function. Oh, hey, this looks kind of familiar. We're subscribing and then running the initial check. Where do we see something that looks awful lot like this pattern? Oh yeah, the plain JS example that I showed.
The one of Dan posted before, or
The one that's just like updating the one div with the stringified value.
yeah, that's what that looks like.
It's
yeah.
that exact same sequence, just more complicated.
Yes.
And so every time an action is dispatched, we're going to get the latest state, run the selector. If it didn't change, bail out. Otherwise, save the latest state and force a re-render.
Whoa. Force re-render. Where are we getting this from? Force render.
Great question. It's a tiny little use
You
reducer
cheater.
up here. So
I've done that before too.
class components have a method called force update built in. Function components do not. Force update and set state are basically identical. Like I said, there's the little nuance of behavior with should component update in classes. But really all it is you're queuing a state update that you don't care about. What is the tiniest possible state update that returns a new value that we don't care about? It's a counter. We don't care about an action object. We don't care about a type. All we care about is that every time this thing runs, it returns +1.
You're using use reducer in React-Redux. It just sounds so funny to think about that. But the interesting thing here is when I've done this, I've used a use state, and then when I set it, I have to do the plussing in the set. And so this is actually a better way to do it because the setting is built into the reducer that you've created.
And they're semantically the same. Use reducer and use state are implemented in terms of each other. You could go either way. It's exactly the same mechanism underneath. At this point, it's just which syntax do you prefer?
I'm a little curious here. Have you done any testing with this if it overflows that value?
I suppose it's hypothetically possible, but we've got 2 to the 53 integer values to worry about.
Okay.
And even if it overflows, going from 19 gazillion to 0
or negative, yeah, depending on if it's unsigned, yeah.
That's a change. That's a change. And also, if your component updated 19 gazillion times while being mounted, well, whatever.
Yeah, well, that's good. I was hoping it wouldn't like buffer overflow or anything weird like that. I actually don't know how JavaScript handles.
I'm pretty sure it would just wrap.
Okay.
So you can see that there's a lot less logic here, and the logic is tricky, but a lot less complicated. But it's also because there's a lot less going on here conceptually. It's just we got a selector, we run it when an action was dispatched. We also render it when the hook and the component render, and that's it. We're not trying to accept multiple arguments. We're not trying to handle map state and map dispatch. We're not handling 7 different legacy options that no one uses. And on top of that, the TypeScript typing for both the code and the usage is drastically simpler. That has a lot to do with why we recommend the hooks API as the default at this point.
Mm-hmm.
It's easier to use with TypeScript. It's easier conceptually. It's a lot more clear to see where you're getting that data from. It's not 100% perfect. There are a couple trade-offs. And if you look at the hooks API reference page, I specifically documented a couple of the edge cases that you can run into. Like, there's still that scenario where a child component could subscribe to the store before its parent.
Yeah.
And thus it could see a state update without having the latest props, or maybe even the parent would re-render it out of existence. It just hasn't had a chance to. Those are possible. In practice, I think we've had more complaints about the fact that these warnings exist on the docs page than we actually have with people who have run into it and been upset about the actual behavior. So basically, I tried to document that this is a thing that could happen. In practice, what is likely to happen is the selector will run in the child first, potentially with some captured stale props. It might return a wrong value. It might even throw an error. We catch it and force a re-render. And then say you've deleted an item out of the store in a list, and your selector is trying to return like state.todos bracket ID .name or something, which would explode if the value is no longer there. that would throw an error, but we catch it and force a re-render. And then ideally, like the parent then has a chance to re-render. The child component never renders again because it's gone and the error just goes away.
Oh, yeah, I think that's a great way to fix the problem in a way that nobody ever has to worry about it. Because I've been worried about this myself too, and like, how do you handle that? And it's nice that you've both handled it, but then you've documented it. Although, like, now I see why you say that people have complained about the documentation, is because it might seem like
it sounds scary.
Yeah, it looks very scary, actually. Even me, who already knows, I'm looking at it, I'm like, yeah, that looks really scary to me. Makes you not want to use them.
I was doing my best to pass on what I'd learned about the possible edge cases and to document it for posterity. And I believe it's better to have the info out there
yes, I agree.
Publicly than like buried in a couple issue comments.
Mm-hmm. You said there was something special about use dispatch?
No, not really. In fact, here's the guts of use dispatch. Ta-da!
That's how I thought it was too. That's awesome. I love it.
You will get dispatch and like it. That's it.
Yes. This is the way I would build it if I was building it myself. You just do store.dispatch. It's in the context. So use store is your wrapper that gets the store out of the context.
Yep, and for that matter, use store is literally just that.
Yep. And then that's that you custom use context thing that you were talking about. There's like because you said you could have custom contexts. So use Redux context. I'm assuming that you could pass a context into it if you wanted to. That's a custom Redux context, or am I missing something?
Yeah, that is it right there.
Okay.
Yeah.
Okay.
You can see the implementation simpler, the TypeScript types are simpler, the concepts are simpler. Let's actually talk a little bit about like where we're headed with like React-Redux version 8.
Yes, I'd love to hear what's next.
First off, you've already seen we've converted the codebase to TypeScript. We'll probably need to tweak the types some more, but I think it's basically there. Another is that Connect Advanced is going to go away. We'd said back in like 2019 in an issue that was deprecated, and especially like once hooks came out, that pretty much removed any additional need for that API.
Yeah, I'm not really sure what it was doing, but it seems like from what you're saying that it allows you to create custom connect functions.
Basically, yes.
Yeah.
So I've actually been thinking about sitting down and trying to do this work here in the fairly near term. Right now, you've got Connect Advanced as this big file with all the component logic. You've got the guts of all the map state, map dispatch. Is it a function? Is it an object? Is it the first render? Is like all that's actually a bunch of pure functions over here. The problem is that the guy who wrote it came from like a .NET Enterprise type background. So this feels very enterprise-y, for lack of a better term. There's a bunch of, like it's like somewhere between like enterprise-y and factory level.
I'm not quite sure what that means.
There was a joke on the Joel Spolsky software discussion board back around 2000. If you Google for like hammer factory, you'll find it. But it's a joke about like, I want to get a hammer. Okay, well, we don't sell hammers anymore. We're going to sell you a factory. But we don't sell factories anymore. We sell factories that make factories. And we don't sell factories that make factories. We repeat as a joke for like all the like object-oriented stuff going on in Java land. The code in here has a little bit of that kind of feel to it. Part of me wants to change it, but on the other hand, it's there and it works. And Connect is not deprecated. We still support it. It'll be there in version 8, but we also have no reason to change Connect at this point.
What if Connect was removed from React-Redux and moved to a React-Redux Connect or some other library?
Someone else suggested that the other day, and there's actually no benefit to it because the React-Redux library itself does tree shake. And so if you only ever import use selector and use dispatch, you will not pay for Connect in your bundle at all. And you can verify this, like go make a basic React app, import use selector, like use it in one component, and then do a build and use source map analyzer to do the bundle analysis as suggested in the CRA docs. And what you'll see is it's about 3 kilobytes. And it's the subscription class, the use selector hook, and then like 1 or 2 other little utility files. And that's it. There's no Connect that gets pulled in.
Interesting.
To remove Connect Advanced, I'm going to need to figure out how to consolidate the component logic in this Connect Advanced file versus the specialized inputs to Connect Advanced that make up the current behavior of Connect. Ideally, I would love it if I didn't have to touch any of these other files that implement the actual logic behind it. we'll see how that manages to turn out. But again, like that'll all be basically invisible to the user. It might end up like shrinking the bundle size by a few bytes, but nothing related to Connect itself should effectively change at all.
Yeah, the only people that would be affected are people using the Connect Advanced API direct.
And there's very, very few of those as far as I can tell.
Yeah.
Really, the biggest change that's going to be happening is related to compatibility with React 18. The React team has put up a working group discussion repository. They've invited a subset of people in the React community to actively participate in that so that they can have the back and forth and people asking questions and, hey, like come up with better examples and stuff, but without like the entire community at once kind of spamming it with questions. But the whole repo is public. Anyone can look at it. And I was fortunate enough to be asked to be part of that. Honestly, most of the info that's come out so far is stuff that I was already aware of because I was kind of involved in some of those discussions going back to like 2018, and because I like sort of obsessively read the repo anyway, you know, that sort of thing. So like I've been very aware of where things are going for a long time. And again, like that issue of tearing where different parts of the tree render with different data because it got interrupted halfway through is still a big concern. The React team actually created a new hook.
Use mutable
source.
So I saw this. I skimmed the PR and I have no clue what I was looking at. I don't know what it does or how it helps and how it's related to Redux, but I know it's for Redux. That's how much I know.
Well, let me see if I can summarize it. So it's a new hook that is built into React. I believe it is available right now in the experimental/alpha builds. Loosely put, it's a way for you to say, here is a data source. I will update the contents of the hook based on my external data source. My other components will read from this adapter. And if React detects that the contents of the data source have changed while it's in the middle of a rendering pass, React will throw away the current rendering pass and start from scratch so that the entire render sees one consistent set of data from that source. Let's kind of imagine this a little bit. And to be honest, it's been a while since I've looked at these examples or the RFC, so I don't remember the exact syntax or options or like exactly how it works. You provide a value and kind of a version. The version could literally just be a new reference of a new value, or it could be like a number or something. It just needs to be something that is distinctly not equal to the last version.
Is that the get state function that we're going to use for Redux?
Let's see if we have. Okay, they actually have a like
get state. Okay.
Redux was not the only use case in mind, but they literally did take Redux into account when they designed this API, and they actually do have a mini example here. The data source is the store. We have a function that returns a version. And because Redux states are immutable, every new state is a new reference, and therefore that can act as the version. We can create a context with the source object. We can subscribe to it. And then we can end up reading a value down here. Like I said, it's been a long time since I've looked at this. Like they did this work like a year and a half ago, at least. Loosely put, the React team is kind of defining 3 levels of compatibility with concurrent rendering. One is doesn't crash, but there could be a whole bunch of tearing. Level 2 is doesn't tear, but React may kind of have to de-optimize some of the concurrent behavior in some scenarios, like pausing a render, throwing away the work, restarting, that sort of thing. And the third level is works perfectly with concurrent rendering. Realistically speaking, I'm not sure anything outside of React can ever achieve level 3. I think the most any external store can ever achieve is level 2. Basically, the plan at this point is that somehow we're going to swap the guts of definitely use selector and probably connect to use mutable source instead of a direct, like our current subscription behavior. So we're still subscribing to the store, we're still getting the data, but we're now putting like a little bit of a React check in between that subscription handling behavior.
This is something I want to know. So I can understand how use mutable source is now used by useSelector, which would significantly lower the size of useSelector even more. The question I have now is, How do you make this work for multiple versions of React?
So that's the thing. We won't be able to. So just like React-Redux 7.0 bumped our React dependency minimum version to 16.8 because we needed hooks, React-Redux version 8 is going to require React 18.
Wow.
We'll keep maintaining version 7 in parallel, partly because like version 7's done. Maybe I'll port over that change subscription from a class to a closure thing because there's no external visible change and it saves like 300 bytes. But version 7 is stable. There's very little, if anything, that needs to change with it. So no problem maintaining that going forward.
That makes sense. And yeah, I mean, it's not like, so here's the thing is Redux isn't really receiving that many changes. And
right.
Yes, and so that would then sustain as long as Redux keeps its same API. Now, even if Redux does get changes, the API most likely wouldn't change, based on my knowledge of Redux.
Yeah, and that's the thing. Like the Redux store API, for all intents and purposes, has not changed since like October of 2015, like 3 months after the 1.0 release. If you look back at the release history, like version 1, 2, and 3 came out in like a 3-month period. And I think it was Dan going back and forth on replace reducer behavior or something. And other than that, nothing meaningful. Like version 4 was just a couple tweaks to the type defs and whatnot.
Oh, interesting.
There's been lots of little releases, but it's all been like change an error message, add another little edge case internally. But your API of dispatch, get state, subscribe, replace reducer has not changed in 6 years. So the Redux core is done for all intents and purposes. Now, we did actually have the main code base converted to TypeScript like 2 years ago. Been sitting in master unreleased since then. And there's a couple reasons for that. One is that I didn't know TypeScript at the time. Tim Dorr, the other primary maintainer, was getting up to speed on TypeScript at the time. We think that there probably still are some tweaks needed to the types if we're moving them into our own repo. And like there's probably a few things we should fix. We just haven't taken the time to think about it. And honestly, if we put out a Redux version 5 right now, there'd probably be some churn in the ecosystem. Like packages would need to update versions, and maybe the TypeScript types don't align right. So now you're causing compile breaks for people. I see some value in getting a version 5 out eventually with the types coming from TypeScript instead of being a separate typedefs file, but there's no urgency to it. Really, Redux 4 is fine. I would like to get version 5 out the door someday, eventually, but there's no hurry to it, and I don't know when. React-Redux version 8 will try to align with React 18. There's no firm date for React 18 coming out, but they're kind of guesstimating maybe kind of end of this year, start of next. So I see that as kind of being kind of a similar timeline here. Redux Toolkit, on the other hand, is where we're doing all the innovation and development on the Redux side.
What happened? That's because the video is so long that I split it into 4 parts. Because it's split into 4 parts, this is the first part, and I'm ending it right here. So he's going to talk about Redux Toolkit next time. But right now, he's just talking about the future, and Redux Toolkit came up, and then that's the end of it. There you go.